Welcome to The Explainer. Today, we're putting on our tech architect hard hats and going completely hands-on. We are going to build a full open-source conversational AI stack, layer by layer, pulling straight from the latest 2026 source data. We're talking about taking raw text models, giving them a voice, connecting them to the real world, and ultimately putting the whole thing inside a moving robot. It's a huge build, so let's jump right in. Here's the blueprint we're following today. 1. The open source bot foundation. 2. Dominating WhatsApp automation. 3. Connecting the backend middleware. 4. Conquering real-time voice AI. 5. Beating RAG latency bottlenecks. And 6. The physical robot frontier. All right, step 1. The open source bot foundation. We have to build that core text layer. Now, in this space, the trade-off between convenience and total control is always shifting. Rasa is still the absolute gold standard for dedicated Python and machine learning engineers who want complete granular control over intent classification. But it definitely has a steep learning curve. On the flip side, you've got BotPress, which gives you this great drag-and-drop visual flow. But based on our sources, for pure business application and rapid deployment, one platform is really pulling ahead of the pack. So why Open Assistant GPT? Well, for developers and agencies, it's honestly the easiest starting point because it completely bridges open source sovereignty with immediate no-code production readiness. You literally just drop in a website URL. And this is key. You bring your own OpenAI key. Since there are zero sneaky vendor markups, your costs stay entirely under your control. Plus, you instantly get a working bot with RAG, Retrieval Augmented Generation, built right in, which grounds the bot in your actual content and kills hallucinations. Okay, so we've got our text brain. Now we need to let it actually talk to people.
Moving on to section 2, dominating WhatsApp automation. Let's connect this thing to the users.
When it comes to routing these conversations, NAN is the clear choice for this kind of architecture over something like Make. Now, Make is great, right? Super useful for simple, non-developer workflows, but we're building a highly custom stack here. NAN gives technical teams total API-level control with a zero vendor lock-in. It lets you transform data, handle some really complex back-end logic, and build workflows that seamlessly talk to external databases and APIs. And here is a massive secret weapon from our source data. If you want to bypass those strict templates and per conversation costs of the official Meta API, you can use the Evolution API. It's a super powerful open-source middleware that essentially emulates the WhatsApp web protocol. Deploying it is just 3 simple steps with Docker. 1. Clone the repo. 2. Spin up the container. 3. Scan a QR code with your phone exactly like you're logging into WhatsApp Web. And just like that, your NN workflow has full programmatic access to WhatsApp. Which brings us to section 3, connecting the backend middleware. Think of this as the brain's routing system. When researchers, like the team at Kempton University, map out standard conversational architectures, you see a very specific logical flow. The user's input moves through language understanding, it hits dialogue management, and then it goes straight into the fulfillment backend. That fulfillment piece is where the actual magic happens. That's the part where your chatbot stops just talking and actually starts doing things for the user. By using a digital-first, low-code platform like Node-RED as your middleware, you can visually route actions from a conversational framework straight into your business systems. Node-RED relies on visual nodes where JSON message objects flow perfectly from one step to the next. So imagine a user asks the bot for the weather. The bot understands what they want, passes it to Node-RED. Node-RED instantly hits an external weather API, grabs the data, and passes the exact temperature right back to the bot. Seamless. All right, section 4, conquering real-time voice AI. It's time to speak out loud. Taking a bot into production voice is a strict 3-stage streaming pipeline. First, you have speech-to-text, transcribing the audio. Second, your LLM figures out the response. Third, text-to-speech synthesizes that audio back to the user. But here's the catch. To avoid that awful robotic dead air, each stage has to stream its chunked output immediately to the next one. You absolutely cannot wait for the LLM to finish thinking up a whole paragraph before you generate speech. You have to stream it sentence by sentence, and you have to be fast. The clock is constantly ticking. And that brings us to this absolutely crucial latency budget, 400 milliseconds. If your total processing time across all those pipeline steps exceeds 400 milliseconds, the whole conversation instantly feels unnatural to a human ear. People start talking over the bot gets confused, and trust just evaporates. This is why co-locating your services and really fine-tuning those voice activity detection thresholds are absolutely vital.
That perfectly tees up Section 5, beating RAG latency bottlenecks with the dual agent solution. How on earth do you maintain that sub 400 millisecond speed when your AI needs to pause and retrieve external knowledge from a vector database? Well, check out this cutting-edge blueprint from Salesforce AI Research called Voice Agent RAG. Instead of making the user wait while the bot searches a database, it solves the problem by separating a background slow thinker from a foreground fast talker. The whole system works entirely in parallel. It's incredibly clever. While the user is speaking, that background slow thinker is actually anticipating where the conversation is going next. It queries the heavy vector database in the background and pre-fills what's called a semantic cache, an ultra-fast in-memory index. It's literally like giving the AI a cheat sheet of answers before the user even finishes asking the question. So when it's the bot's turn to speak, the foreground fast talker just checks that local cache, and the answers are already waiting.
The results of this dual agent architecture are honestly staggering. By reading straight from this cache, the system gets a 316 times retrieval speedup. It drops the database lookup time from 110 milliseconds down to just over a third of a millisecond. It completely obliterates the RAG latency bottleneck, keeping the voice bot lightning fast and incredibly smart. And finally, Section 6, the physical robot frontier. Let's give this AI a body. The Home Assistant developer community is doing something wild right now. They're taking standard commercial vacuums like Roborox, entirely bypassing the manufacturer's cloud, and hacking them using open-source tools like ESP Home. By attaching a tiny voice satellite, like a ReSpeaker mic array powered directly from the vacuum's battery, they're turning an everyday appliance into a fully autonomous voice-enabled roaming assistant that, hopefully still cleans your floors. Developers are realizing that robots fundamentally break the stationary barrier of modern smart homes. By funneling our entire open-source AI stock, the text understanding, the Node-RED middleware, that sub-400 millisecond voice streaming, into a mobile chassis, our AI can finally navigate physical space. It can drive to a specific room, act as a roaming media player, and physically react to commands in real time. So we've basically just architected a system that goes from a simple text input all the way to a physical robot roaming your house, and it is entirely built on open-source tools where you own the data. The tools to build autonomous, voice-enabled physical AI aren't locked behind massive enterprise paywalls anymore. They are completely open source and sitting right in front of you. The ultimate tech stack is in your hands. So, what are you going to build today?